Hi, this is the introduction to the course on the advanced machine learning, which we will be delivering over the SWAYAM platform. Myself, Professor Amlan Chakrabarti from the School of Information Technology of University of Calcutta. So in this course, we will try to deliver some of the very important tools and techniques related to advanced machine learning, starting from the basics of regression and some of the key issues of the machine learning. And then we will go to the advanced topics, basically focusing or emphasizing on the deep learning networks, where we should see the various forms and various variations of the neural networks, which can help in classification and pattern recognition from the data and can make our systems very intelligent. These systems have a lot of applications, starting from the domain of biomedical, health engineering, going through the crops and agricultural analytics, and then focusing on cybersecurity and forensics. Obviously, business and finance will always be a good application area for these machine learning algorithms for predictions. So I hope that you will enjoy the course very much, and we will have enough impetus in this particular course so that you will learn and you can apply the knowledge in the domain of activities you are doing. This video will be a brief introduction of my course to advanced machine learning. So in this video, I will try to introduce what is machine learning and how the advancement of machine learning has been done through the deep learning techniques. So when we tell about machine learning, which started conceptually from 1950s and has progressed over the years to a lot of transformations. But basically, it is a technique by which we try to build computer programs not based on our algorithms, which we normally try to work out, but based on the data what we have from a particular domain. So we can define, or we can very loosely state, that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. This was actually stated by Arthur Samuel in 1959. So the other things what we can attach to machine learning is learn from experience. So the experience comes from the study and analysis of the domain and obviously the data what we have in the domain. There are some performance measures which are related to machine learning, which will constantly evaluate the machine learning algorithm to make it better and better, such that it can adapt with the changing or the variation in the data captured. So as we see in the figure, this is a very good way of explaining what machine learning is. So machine learning develops models which are based on the training data, and these models are tested by again another set of data which are called test data, and then we try to evaluate the performance. There is a sort of performance metrics or evaluation which is done. Through this, we try to minimize the errors in the model so that our prediction is close to the accurate value based on the data and the outcome what we already know. Once we develop this particular machine learning model based on a large amount of data, and obviously which gives us a very low prediction error, or we can also have a classification type of approach at the outcome of the machine learning. Then we try to deploy this for the systems so that they can work based on the model what we have already developed. Now, when we try to go to the farther or to the advanced level of machine learning, which we normally coin as deep learning, It differs in the way that these deep learning networks have their inherent capability to understand the data. So the machine learning, what we normally call the machine learning techniques, here there should be a player, or we can tell the user, who will try to look into the data and try to give some keys or some features to the model, by which the model either predicts or classifies the data. Vis-a-vis, when we see the deep learning models, we will see that this particular technique of extracting the features are mostly automatically done through some iterative processes, which are done not through a small network but to a larger network of processes. And this actually works a very automatic way to extract the features and to classify or to predict the outcome and to give us a result. So the things what we will be discussing in this particular course, advanced machine learning, we will be focusing on the various facets of this deep learning. Covering in the initial stage, we will cover some of the very salient features of machine learning, like regression, like ensemble way of classifications, and then we will obviously an introduction to the neural network approaches, just to understand the advanced topics in this particular course, which inherently focuses on the deep learning. So the objective of this particular course will be to focus on the concepts, or to learn the concepts of advanced machine learning concepts, where we will discuss, or we will actually state various methods of algorithms for classifications, regressions, clustering, probabilistic model, along with the deep neural network concepts and their various ways of construction of deep neural network models and their implementations. This course aims to equip the students or the learners with the machine learning skills to design powerful AI systems, which means that which can distinguish, which can do object detection, which can do pattern recognition for very complex objects, or for very difficult scenarios which our normal machine learning systems might fail. Intelligent agents, which will be a sort of building blocks to develop the systems, develop the intelligent systems and the communication based on the different types of deep learning models. Neural networks, which builds on the fundamentals of the deep neural networks as well as the classical neural networks. We will have a good emphasis on these particular topics. And then we will learn the various machine learning models, the various logistics models, knowledge-based systems, and decision-making functions, which will be well supported by a lot of techniques in terms of the coding in the various platforms, specifically Python, and a lot of assignments and some mini activities, so that you can aptly build your own systems, be it is an image classifier, be it is a text classifier, or be it is a complex pattern recognition algorithm, or prediction for a lot of activities like financials or stock predictions. So I expect that the outcome of this particular course can be envisaged based on the learning capability of the students in terms of the knowledge in the designing of the AI systems, intelligent agents, ensemble learning, neural networks, and deep learning models. Okay. As I told, that we will try to illustrate, and we will demonstrate that how these things can be used to develop your own models for some good number of applications. This will also give the underlying mathematical concepts so that we not only can understand but can also sort of aggregate the concepts based on the mathematical and based on logical functionalities, and can build our own models which can be a variant of the existing ones. Obviously, we will focus on some of the real-world applications so that so students of this course can able to build some real-life applications. Either it's a domain of computer vision, or it's a domain of prediction, weather forecasting, pollution monitoring, or financial predictions. The course has been divided into 14 weeks, and so I present a brief structure of this particular course. And if we see that the initial weeks are just to give you the knowledge of the fundamentals of machine learning, the concepts of fundamentals of machine learning, starting from regression and then the ensemble classifiers. Then it progresses on to the neural network, the various forms of neural network, and then we get into the advanced machine learning concepts, basically on the deep learning concepts, which uses a type of network which is a pretty variant, or a very complex variant of the neural network what we know. So it actually helps to understand a more complex domain of data with a very high precision. And obviously, when we look into the deep neural network, when we will go into the deep neural network course, we will see the ways how we can construct the architecture, how we can tune the deep neural network so that it serves the need of optimization. And then we will move on to the convolution neural network, which is also one of the very talked about a network model, mostly used for computer vision, for image classification, object detections, and also the speech processing. Further, we move on to the recurrent. From the week 10 and 11, we will discuss the recurrent neural networks, which is a bit different from the very common convolution neural network, in the terms that it uses memory. And we will see that how utilizing the memory, that means it can predict a sequence, or it can analyze a sequence better. When your data is in the form of a sequence, it may be a sequence of words which builds a sentence and tries to understand the semantics. Then we will find the recurrent neural network works in a very intelligent way and can work very fine compared to the deep neural network approaches. And then we will move on to the autoencoders in the week 12. So autoencoders is a sort of feature compression or dimension reduction in the domain of the deep neural network feature space. Compared very equivalent to the PCA, what we do in the classical machine learning. But what it helps the autoencoder is that it can squeeze out the feature space, and it can use the squeeze feature space for training your network, and that helps to reduce the time in the terms of training and to work with a large amount of data. We will also touch upon some of the variants of autoencoders, like the restricted Boltzmann machine. So instead of a large network, a restricted Boltzmann machine actually works on two layers, and it works on the forward and backward pass and tries to understand the insight, the feature dependency, say among in the given data, so that the feature reduction can be done in a very efficient way. In the week 13, we will focus on the GAN, which is called Generative Adversarial Network. This is a very new thing which just started in 2014, and this GAN is a technique by which we actually generate competitive models, and through competitive models we can understand the finer features in your data, okay, and can create models which can use those finer features and can prove that these models are best compared to the models we can normally build up. So it's a very useful technique, and we will have a discussion in the last phase of our course. And finally, we will conclude in the lecture 14, followed by final assessment. So you have gone through the basics or the introductory content of the course of Advanced Machine Learning. What we have discussed is the key things to be discussed in this course, the learning outcomes, the schedule of the course across the various 14 weeks of the duration, and the way we start from the basics to the advanced topics in this course. We will have a lot of assignments. We will have a lot of ways to test our programs based on the techniques what we have learned. And finally, we will close with a final assessment of the course. This course, I believe, will be very helpful for the data scientists who are in practice, the students who are trying to get into the data science, and obviously some of the people who are trying to focus on developing innovative products in the various application areas. We will try to do our best to fulfill the satisfaction and fulfill the requirement of the students and the practitioners in this domain. And I hope that this will be a marvelous training program for all of you.